Consider the differential equation dy dx is equal to 3. So three people have different solutions to this differential equation. So Larry says that y is equal to 3x plus c. Curly instead says, no, it's 3x plus 2c. And Mo says, no, you're both wrong. The general solution is 3x plus c minus 5. So who's right, ultimately? Well, all three of them actually work when you plug them into the differential equation. Which one is the true general solution? Well, all of them are actually a general solution. You can rewrite your general solution in different ways. Now, what happens when we impose an initial condition? So let's give the initial condition y at x equal to 0 is 5. So now Larry says that c must be equal to 5 for him. Curly, on the other hand, says no, c is equal to 5 halves. You got it wrong. And Mo says, of course, both of you are wrong. C is actually equal to 10. Well, if you plug those back into their respective solutions, they all get the same solution, y is equal to 3x plus 5. So this illustrates a general point, which is that a general solution can be written in many different ways. But specific solutions, or particular solutions, that you get from imposing initial conditions are actually unique. And that's a really important point. So let's look at another example. So dy dx is equal to y. The general solution to this is, of course, y is equal to c e to the x, as you can check by plugging it in. So is y is equal to e to the x plus c a solution to this? Well, if you plug it in, it definitely seems to work. Is it the most general solution? Well, it looks different than our other general solution, but you can actually make them look the same if you write this as e to the c times e to the x, and then just call e to the c some new constant, c twiddle. After all, this is just some arbitrary constant, either c or c twiddle. These are arbitrary constants. It's not really clear what it should be, so we could just rename it to something. And now it looks like the same general solution we had above. Okay, let's look at one more example. So the general solution for the differential equation dy dx is equal to y plus x is y is equal to c e to the x minus x plus 1. And you can trust me on that. So I have a number of other possible solutions, and we want to know, are these also general solutions? So let's see, e to the x plus c minus x plus 1, is that a solution as well? Well, you can write that as our general solution that we have above by writing e to the x plus c, as we did above, as c twiddle e to the x. And so the solution looks like c twiddle e to the x minus x plus 1. And that looks like what we have. So yes, that's a solution. How about c e to the x plus d minus x plus 1? Now there's two constants, c and d. Yes, this is still a solution. And again, you can rewrite e to the d and c as total one other constant. Let's call c twiddle. Here, though, note that c and d are not actually independent of each other. You're only allowed one independent constant here, not two. And so c and d we've combined into one overall constant that we're calling c twiddle. How about c times the quantity of e to the x minus x plus 1? This actually is not a solution, which is easy to see by distributing the c through. Now you have a c multiplying the x plus 1 term. In our general solution above, we didn't. And so actually, if you plug this in, this actually isn't even a solution.